Hi guys, so I can't do a live stream tonight, so instead we're going to do our quads live stream, not live. So you can pretend watching it live. Feel free to still send me questions on Remind. But again, this isn't live, so you're watching it on a replay. So we're going to start with our quad properties. Remember that this document is on my teacher site, so if you want to see it, go there to grab it. These are the big quadrilaterals that you need to make sure that you know. We've got parallelograms, rectangle, rhombus, square, and a trapezoid. So I'm going to start with trapezoid because that's kind of our broadest category of special quads. And a trapezoid always has one pair of parallel sides. That is by definition what a trapezoid is. Now it can have more than one pair, but it needs to have at least one pair. Because it has parallel sides, right, these are parallel, I'm going to have consecutive angles supplementary because those are same side interior. And then if it's isosceles, you know legs are congruent, base angles are congruent, and diagonals are congruent. So those are my big properties of a trapezoid. Below trapezoid, that's one pair of parallel sides. Now if I get two pairs of parallel sides, I have a parallelogram. And again, 5 big properties of a parallelogram. Opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles are supplementary because we have parallel lines, and diagonals are diagonals are not congruent. That's wrong. Change that. Diagonals bisect each other. Okay, so diagonals of a parallelogram bisect each other. In a rectangle, that's a type of parallelogram, which means all of the properties above hold true. And then we also have 4 right angles. When you see rectangle, think right angle. And we also have congruent diagonals. This property always comes up on the Regents. Okay, rectangle has congruent diagonals. For a rhombus, all the properties of a parallelogram, and then all congruent side, diagonals are perpendicular, and diagonals bisect the angles. And again, this property always comes up on the Regents. If there were 2 properties that I would say make sure you have memorized, it would be those 2. Rectangles have congruent diagonals, and rhombus have perpendicular diagonals. And then a square is a rectangle, is a rhombus, is a parallelogram, is a trapezoid. So a square has all of those properties. A square does not have unique properties. It just has all the properties of the other shapes that it also is. So we're going to go through and look at some real Regents examples and see how we could apply this. Right, quadrilateral ABCD has diagonals AC and BD. The first thing I'm going to do is draw this. So quadrilateral, and I'm going in order, A, B, C, D, has diagonals AC and BD, okay, which is not sufficient to prove it's a parallelogram. So let's see. AC and BD bisect each other. So that is saying that my diagonals bisect each other. That, in fact, proves that is a parallelogram. That's a property of a parallelogram. So one would work, and it says which would not work, right? 2, AB is congruent to CD, and BC is congruent to AD. Well, that says opposite sides congruent, and that is a property of parallelograms, so that's gone. Okay, the next one, AB is congruent to CD, and AB is parallel to CD. Well, if you have one set of sides congruent and that same set of sides parallel, that does in fact prove that it is a parallelogram. So we know it must be 4, but let's see why. So this says that these are congruent and that these are parallel. All that proves to me is that this is a trapezoid. So if I had that, right, these could be parallel and these could be congruent, and that would just be an isosceles trapezoid. That doesn't necessarily make it a parallelogram. So I know my answer here should be 4. So again, knowing those properties is really important. All right, next one. Again, you will see this question every year. A parallelogram is a rectangle if diagonals are congruent. Diagonals perpendicular makes it a rhombus. Opposite sides parallel makes it a p-gram, and opposite sides congruent makes it a p-gram. All right, next one. Diagram of parallelogram FRED. So I know this is a parallelogram here. ED is extended to A and AF is drawn such that, and this is really important, AF is congruent to DF. So I see there that I have an isosceles triangle. 2 equal sides should signal in your brain 2 equal angles. So those base angles are going to need to be congruent. I already know that. I also know that this is a parallelogram, which means my opposite angles are congruent and my same side interior angles are supplementary. So measure of angle R is 124. what is the measure of angle AFD? So that's this angle up here. Okay, so let's see what we can figure out. So I know that this is a parallelogram, so opposite angles are congruent. So if angle R is 124, angle EDF is also 124 because those are opposite angles. Now here I see that this is a linear pair. These make a straight line. So I'm going to do 180 minus 124, which should be 56 degrees. Now, congruent sides, congruent angles, so this is also 56. And then I see that this is a triangle, so these need to add up to be 180. So that's 56 plus 56 plus x equals 180. So I'm going to do 180 minus 112, and so that is 68 degrees. Okay, those properties really matter. All right, next one, and again, if you want this document's on my teacher site, go there, okay? You will find it. So the next one says, we have a parallelogram, so lots of properties there. I know that the measure of angle S is 60. The measure of SRT is 83. The measure of TWU is 35. And what is WVQ? WVQ, so that's my unknown. So I'm just going to start by figuring out what I know using properties of parallelograms. So first of all, I know that these two sides are parallel, which makes this 83 alternate interior with that 83. So it's a parallelogram. I have alternate interior angles. The next thing I'm going to do is I'm going to use the fact that opposite angles are congruent. So I know that this is 60, so I also know that that is 60. And I want to figure out this angle right here because that's going to give me all four angles in this quadrilateral. Okay, so to figure that out, well, I know that this is a linear pair. So I can do 180 minus 35, so this is 145. I know now that I have a quadrilateral right here. Okay. And so now I know those need to add up to 360. So 60 plus 83 plus 145 plus x equals 360 because the sum of the angles in any quad is 360. So 60 plus 83 plus 145 is 288, and 360 minus 288 would be 72 degrees. Okay, let's look at the next one. I've got this quadrilateral with these vertices. Which type of quadrilateral is this? So is it a rhombus, rectangle, square, or trapezoid? So let's start by maybe graphing it out. That would be a good plan. So -3, 1 is here. 0, 3 is here. 5, 2 is here. And -1, -2 is here. So looking at this, I might just be able to tell what it is. But, so if I actually want to prove this, let's look at what I do. So let's say I call this A, this B, this C, and this D. So that's A, B, C, and D, right? So I'm going to find my slopes of each of these, AB, BC, CD, and DA, and I'm going to find the slope of each of those. And so for each of these, I'm going to do my change in Y over my change in X. So between A and B, it's 3 minus 1 over 0 plus 3. So that's 2 over 3. For BC, it's 2 minus 3 over 5 minus 0. So that's -1/5. For CD, it would be -2 minus 2 over -1 minus 5. So that is -4 over -6, which is 2/3. And you guys can't see that. And for DA, it would be -2 minus 1 over -1 plus 3. So that's -3 over 2. So what I see here is that I have one set of parallel sides. Yes, I have a set of perpendicular sides, but you know what? That's not enough. One pair of parallel sides means that it is a trapezoid. All right, let's get into some free responses here. So here's the first one. It says, the diagram below is given. This is a parallelogram. Angle M is 118, and angle LNO is 0. Why is NLO also or why is it 40 degrees? So let's figure out what we can here. I know here that opposite angles are congruent, right, in a parallelogram. So if M is 118, so is O. And I want NLO. This is what I'm looking for. So this is really what I want to know. So now I'm going to say, okay, well, 118 plus 22 plus X needs to equal 180. This is 140 plus X needs to equal 180. So X equals 40. So that is how I actually solve it. Now it says explain, and explain on the Regents means put it into words. So what I would say here is, since LMNO is a p-gram, opposite angles are congruent, right? So angle O, the measure of angle O, is 118 degrees. Then, since LNO forms a triangle, I know the measure of angle O plus the measure of angle LNO plus the measure of angle NLO equals 180. Therefore, measure of angle NLO equals 40. So just explaining what you did in words. Okay, so now let's look at a coordinate proof. This is a really common type of proof. It's something that I would almost guarantee you're going to see. And so this is what I would make sure that we know how to do. So we're going to walk through this kind of step by step. So RST, R is at 6, negative 1. So 1, 2, 3, 4, 5, 6, negative 1, that's R. S is at 1, negative 4. And T is at negative 5, 6. Okay, so there's my triangle. And the first thing it says is to prove that RST is a right triangle. So I'm going to do this. To show it's a right triangle, I want to use slope. So I'm going to find the slope of RS, ST, and TR. And you are looking for perpendicular slopes, right? So you can do this either by just counting on the graph or by doing slope formula. I'm going to just count on the graph. So if I do RS, I go up 3 over 5. So change in Y over change in X is 3/5. For ST, I go down 10 over 6. Yeah, so this would be change in Y over change in X would be negative 10 over 6, which is negative 5 over 3. And actually I could stop there because I already see I have 3/5 and I have negative 5/3. And those are perpendicular to each other. So what I would say now is that I know RS is perpendicular to ST because negative reciprocal slopes imply perp. And that means that angle S is a right angle because perp implies right angle. And that means that triangle RST is a right triangle because a triangle with one right angle is a right triangle. So that's the first part of my proof. That's the part of my proof that shows that this is a right triangle. So check that off. So now it says state the coordinates that would make this a rectangle. Make this a rectangle. Okay, so let's find that coordinate. So I know that rectangle will need opposite sides parallel. I already know this is a right angle. So as long as that other side is parallel, I'm going to have a right angle. So now let's look at this. So now I would say, okay, from here I go up 3 over 5. So from TR, I'm going to go up 3 over 5. And that I'm going to call point P. And that should give me a rectangle when I graph it. Okay, so I cleared this, and now I'm going to prove that this is a rectangle. Okay, so I'm going to take my four sides of the rectangle. So S, R, R, P, P, T, and T, S. Those are my four segments. And I'm going to find my slope. So change in Y over change in X, change in Y over change in X, change in Y over change in X, and change in Y over change in X. Those are my setups. So for SR, I'm going up 1, 2, 3 over 1, 2, 3, 4, 5. So SR is up 3 over 5. Okay. Now ST we already showed before was down 5 over 3. TP is up 3 over 5. We constructed it that way, right? So that should be the same. And this one, if we actually do our slope, is the same, down 5 over 3, or down 10 over 6. So I see here that I've got opposite sides parallel. So I can say here that, I'm going to write it over here, SR is parallel to PT, and RP is parallel to TS. And I know that because equal slopes imply parallel. And that means I can say RSTP is a p-gram because opposite sides parallel implies p-gram. And that is behind my face. There you go. I can see it. Now, why is it a rectangle? Well, I have a right angle. So I can say here the proof that I used before, right, that like TS is perpendicular to RS. We showed that before. Because the negative reciprocal slopes imply perp, and angle S is a right angle. And I know we had all this before, I'm just rewriting it. So angle S is a right angle because perp implies right angle. And then I could say that that means RSTP is a rectangle because a p-gram with one right angle implies rectangle. Okay, cool. And you wouldn't need to show all of this explanation again because you had already done this above, right? I just had erased it. Okay, so let's go to our last two questions, which are both proofs. And both of these are non-coordinate proofs, so regular old proofs using quad properties. So let's look at the first one. I know that this is a parallelogram. That gives me lots of properties. And it tells me that BE is perpendicular to CED. So that's perpendicular. There we go. DF is perpendicular to BFC, so that's perpendicular. And CE is congruent to CF. Okay, prove that this is a rhombus. So if I want to show that this is a rhombus, I already know it's a parallelogram. So if I can show that it's a parallelogram that has two congruent sides, or that has perp diagonals, I'll know that it's a rhombus. I don't have the diagonals here, so perp diagonals isn't going to work. So instead, let's try to show that we've got two congruent consecutive sides. And remember, at the end of the day, every proof boils back down to a triangle proof, okay? So I know this side, and I know that's a right angle, and I want to know something about the side of the rhombus. So I'm going to use that triangle. And then I also know this side. I want to know something about the next consecutive side. So I'm going to use that triangle. So my goal is to prove those two triangles congruent. Okay. So let's start with what we know. So statement and reason. Again, on the Regents, you will rewrite your whole given, but I am not for the sake of time here. Okay. So I'm going to start with this. Perpendicular will give me right angles, right? So perpendicular will give me right angles. I see here that I have this side already. I can get this. And I'm going to have to think about what else I can get there. So, okay, right angles. So I'm going to say angle, and I'm going to actually erase these marks that I drew in. I'm going to call this angle 1 and that angle 2, because those would both be right angles. So angle 1 is congruent, or angle 1 and angle 2 are right angles. Because perpendicular implies right angle. And then I can say angle 1 is congruent to angle 2 because all right angles are congruent angles. So now what else can I show? So what I see here is that I have an overlapping angle. This angle C is in both of those triangles. And so what I can say here is angle C is congruent to itself. And anytime that happens, that's by reflexive property. And so now let's look what I have. I'm just going to erase this so I can see my markings. I got a right angle, I got this side, and I got that angle. So these are congruent by angle, side, angle. And the triangles are BEC is congruent to triangle DFC. Okay, so now let's say what that gives me. I want two consecutive sides congruent. So I can now say that BC is congruent to CD. BC is congruent to CD. And I can say that either because congruent triangles implies corresponding segs congruent, or because CPCTC, just make sure you abbreviate it correctly. Oh my goodness, sorry. There we go. And then if that's true, that means ABCD is a rhombus because 7, it is a p-gram with two consecutive congruent sides. Implies rhombus. Okay, so not the easiest proof, but again, everything boils back down to a triangle proof. And then if you know it's a p-gram, well, what would make it a rhombus? You would need some congruent sides. All right, last question is this one. So I want to show that AE is congruent to CF. And they tell me that AB is congruent to CD and AB is parallel to CD. And I have fire alarms and bells and whistles going off in my head because one pair of sides, congruent and parallel, tells me that I have a parallelogram. So I'm actually going to start with that. My first thing after my given is going to be to say A, B, C, D is a p-gram. And that is because we have a quad with one pair of parallel and congruent sides. It tells me that I have a p-gram. And from here, everything else shakes out. So I know I want this piece and this piece congruent, right? So what I need to do is I need to figure out, well, what triangles are those in? So I'm going to go with this triangle and that triangle because those are the only triangles these are a part of. So let's start with what we know. AD would have to be congruent to CB because in a p-gram, opposite sides are congruent, and I know you can't see that. I'll move it up in a second. All right, angle 1 here would have to be congruent to angle 2 there. Because, and actually I need to move this down a step. First I need to say that means my lines are parallel. So this would be 5. All right, so 4 would be that AD is parallel to BC or CB because a parallelogram implies opposite sides parallel. That means those angles are congruent because parallel lines cut by a transversal implies alternate interior angles congruent. So now I have that side and that angle. And then I also know that these are perpendicular. So that means that these are right angles. Okay, we got cut off there. So these are right angles. That's what we were saying. We were saying that angle 3 and angle 4 here are right angles. So then what I said was step 6, that angle 3 and angle 4 are right angles because they're perpendicular. And then angle 3 must be congruent to angle 4 because right angles are congruent. So now, when I look at this, I have, let me change my highlight color, or let me actually just change this color. I have angle, angle, side, right? So these two triangles would be congruent by angle, angle, side. So triangle AED is congruent to triangle CFB. Because of angle, side, angle. That was my classroom light going out. And then that lets me say the last step, which is that those are corresponding parts. So AE is congruent to CF because either CPCTC or triangles congruent implies corresponding segs congruent. All right, so that is all I have for quads. Again, I know some of these proofs are tougher, but quad proofs boil back down to a triangle proof, right? And make sure you know your properties, study those, and send me any questions that you guys have. I hope you have a great day, and I'll see you later. Bye.